Thank you. Should be attentive. Should be attentive. The topic, the name of the topic here is calculating. This is still calculations. Calculating water of crystallization. I write water of crystallization. This you see here, the name of the topic, water of crystallization. So what is that? What is water of crystallization? This is water with certain amount of crystal. Okay, certain mole of water with ionic compounds, ionic crystals, which are mostly salt. I show you one example. Suppose here you see sodium sulfate. This is an ionic compound, right? Isn't this an ionic compound? You know, ionic compound. And this is also salt. You will learn about salt later in the next chapter, the acid-base salt chapter. So this is a salt, ionic compound and salt. Here, and salt, as ionic compounds have high melting and boiling points, right? Ionic compounds have high melting boiling points, and mostly they are soluble in water. Like sodium chloride is a salt, you know, common salt that dissolves in water. And when dissolves in water, the salt disappears, right? But the salt can again be crystallized. What's the crystallization? If you concentrate the solution, I mean, heat to remove large amount of water from the solution, then the solution will be, how will be the solution? Concentrated, okay, or saturated. Understand? When you remove many of the water from the solution, then the solution will be concentrated, right? And if concentrated solution is cooled down, just left for cooling, then crystal will deposit at the bottom. Okay, so you are getting the salt crystals. Crystalline salts are solid. When solid, they are crystalline. You are getting the salt, crystalline salt. Okay, and how is that made? By cooling a concentrated salt solution. Clear? And many of the salts are crystallized with some water. With some water. Suppose this is the salt without water. Here you don't see any water with the formula of the salt, right? This is sodium sulfate. And I say many of the salts crystallize, I mean forms the solid with some water. Okay? So suppose here NH2O. This is the total formula. Total formula. This is called hydrated crystal. What is it called? Hydrated crystal. Hydrated means with water. Okay. Yeah. Despite of the water, it's a small amount of water, maybe 2 mole, 3 mole, 4 mole, 5 mole, like this, with certain mole. Despite of the water, this is still solid. Okay. So you know we are mostly made of water, right? We ourselves made of water. Life's made of water, mostly water. Some solid things also in our body, but there are many liquids in our body. But are we liquid? No. We are solid, right? So this is the way you can think that despite of some water, the salts are solid, crystalline solid. Okay, and if you add some more water there, the salt will dissolve. If you add some more and more water, this is minimum amount of water. Okay, naturally set a ratio, minimum amount of water. This is crystal. Okay, and we call this hydrated crystal. And our topic is calculating this value. This is called water of crystallization. Water of crystallization. So how many mole of water there? N is the value of N. Maybe 1, maybe 2, maybe 3, maybe 4. That's the value. Okay, understand? So this is our job to calculate. And to calculate this N, the calculation process is very similar with calculating empirical formula, just you have done just now. Okay, empirical formula, right? Just for ammonia, just to have estimated the empirical formula of ammonia. So this calculation is very similar with that. Okay, how to do that? So you need this pure salt without water. Here this is this hydrated crystal? Is this hydrated? This is hydrated, right? Hydrated means this should be with water, with some mole of water. Okay, and this is non-hydrated. Non-hydrated is not a word, it's anhydrous. What do you call this? Anhydrous, when this is free, dry. This is also dry, but with some water. And water. Look, so you need to have the masses of the anhydrous salt and mass of water. Okay, if you have this two in the compound, in the whole compound, there must be certain amount of sodium sulfate there, right? There must be certain mass of sodium sulfate there, and there must be certain mass of water there. Okay, if you come to know, or if you have the values of these two separately, these two are separate values, then you can calculate the value of n. Okay, so our target is to calculate n, how much water there. This is our job. This is our there, and this is called water of crystallization. And to calculate this, you need mass, right? Which masses? Mass of the anhydrous salt and mass of the water there. Okay, so suppose this compound has, in total, the compound may have mass 70 gram, suppose. Okay, 70 gram, and out of 70 gram, this is alone is 62 gram. If this is 62 gram, then what would be the mass of this water alone there? 8 gram. Understand? Total, I said total is 70. If this is 62, then the other 8 should be water. Okay, this is how the masses are involved in the compound, in the hydrated crystals. And we actually don't know the values. Suppose this is x gram. Okay, x gram sodium sulfate has combined with y gram of water there. Okay, and if this two you have, then you can calculate. What to do? This calculation is very similar with the calculation of estimating empirical formula. There is a, you will have to divide them, both of them, with what? What? Molar mass, right? Molar mass. We are going to convert them into their respective mole. To convert them into their respective mole, you should divide them with their molar mass. So what should be the molar mass of this to be divided? I think that this is Z. Suppose this is Z. Don't worry about this now. Suppose this is Z is the molar mass of this, and what's that? M is the molar mass of water. Okay. So after you divide them with their respective molar masses, you will get moles. Okay, you will get moles. Maybe you will get moles like this. This is 0.1, this is 0.5. Okay, if you get moles like this, the 0.1 and 0.5, then again you will convert them into the simplest ratio. How is that? How to convert them into the simplest ratio? Multiply with no. Yes, divided with the smallest number. That's the way. If you divide both of them with 0.1, what you get? 5, and this is 1. Okay, so this is the calculation. This calculation is finished, and this you get the 5 here. This 5 is the value of n. This is finished. Understand? So what I say, in the last class, we learned how to calculate empirical formula. And in that case, you had this atoms, right? To calculate empirical formula, you work with the atoms, right? Atoms, mass of one atom, mass of the other atom. Maybe you have percentage by masses, mass of the atoms. And in that case, you have divided them, the masses, into their respective RAM, relative atomic mass, to convert them into their mole of atoms. Then the ratio, okay, the simplest ratio. This is how you got the empirical formula. And this calculation is also very similar with this calculating empirical formula. You should have the masses, separated masses, which together is the mass of the compound. Okay, and if you get the masses, you will divide them with their relative masses or their molar masses to convert them into their mole, and mole ratio. From the mole ratio, with the digit, with the values 1:2 something, something is the value of n. Are you clear? Are you clear? Do you have anything more to ask me about this? No. So we see one. Just see one. Here you see one. Look at the question. Look at the exercise, everybody. Look at the exercise. Here you get a sample of magnesium sulfate. Is this hydrated or anhydrous? What do you see? The formula? Hydrated. Here you see X mole of water with 1 mole of magnesium sulfate. Okay, this is the formula. Clear? And it says in this compound or in this formula, hydrated crystal, you have this gram water. How much water here? 8.9 gram. And how much anhydrous other than water? Remember, other than water. How much magnesium sulfate alone there? This is there. So calculate the value of water of crystallization. This is there. Okay. So how to calculate them? Very simple. Just write the formula side by side. Magnesium sulfate and water I write. Clear? Okay. See this? Very simple calculation. Now get. What's the value of magnesium sulfate given here? 8.9 gram. And what's the water here? 8. The first one was 8.3 and next one was 8.9. Is that? Yes, 8.9. Yes. Okay. Thank you. And I'm going to divide them with their what? I'm going to divide them with their respective relative formula mass. These are given here in the question. These are given, right? What's for magnesium sulfate? 120, right? And what's given for water? 18. Okay. What do you get? What do you get? The first one is 0.07. What's the next one? 0.55. Okay. So we get this. Now we need to convert them into the simplest ratio. How to do that? We need to divide both of them with the same thing, right? 0.07. So this will give 1, right? And what this will give you? And this is also 0.07, right? And what do you get? First one will be 1 and second one, what do you get? 7. What do you get here? 7.14. 7, very close to 7. Okay. What I say, these are experimental values. The masses given there are experimental value. So experimental value may not be 100% correct. So you need to round up. If this get 7 point something, very close, should be very close, not should be more than 7.1. If this is more than 7.1, like 7.5, then you cannot take the round figure. Okay, round up is not there. And round up is there when it's very close to 7, maybe 7.1 or maybe 6.9 to be treated as 7. Clear? So now this calculation is finished. What's the value of X here that we're supposed to estimate? 7. This is the value we have calculated. What's the value we have already calculated? This is 7. 7 is answer. Okay. So the question, calculate the value of water of crystallization. Clear? Everybody clear? Everybody clear. Now another thing. We need to add here one more thing here to be added. Come back. Come to the board again. So again, this was what? This was magnesium sulfate, right? Wasn't the crystal magnesium sulfate? And with some water. What was the water? X mole of water. in the question, just you have practiced. In the question, you got their separate values given, right? The separate values were given in the question, right? What was the mass of magnesium sulfate alone given? What was given there? 8.3. And what was the water given? 8.9. But now I'm gonna explain how to get them. How to get the masses, separate masses from this compound, from this hydrated crystals. So here is an experiment. Excuse me, here you need to have an experiment to determine their separate masses. Understand? This is a simple experiment to determine how much water here with how much magnesium sulfate. To know this, how to get this is here as an experiment. For the experiment, you first need to have a container. This is a container, okay? Any kind of container where you can put the salt and can be heated, okay? The heat, and you measure mass of the container alone, okay? Can you measure mass of a container alone with a balance, okay? And what could be the mass? Suppose this is 100 gram. Suppose it could be any, but it's like 100 gram of 100 gram. Okay. Now take some sample. Where's the sample? Hydrated magnesium sulfate here, right? Hydrated magnesium sulfate is some sample, and again measure it with the sample. What the mass you would expect this time? Yes, more than 100. Maybe here 110 gram. Okay, more than 110 gram. Okay, how many things are here? 100 gram. How many things are here? One. And which is the thing here? Only the container. Okay, only the container. And how many things are here in this? I said 3. Which are 3? Yes. Very good. Yes, very good. If you said 2, that's also right. One is container, right? One is itself the container. Container is also here. Another is magnesium sulfate. So this is second one. And third one is water. So 3 things together gives this mass. Clear? Now the main part of the experiment, that here get the sample with container and heat strongly. Okay? For some time you will heat the hydrated crystal strongly. And what would happen, you guess? If this is heated, what should happen there? Yes, water will be removed. Okay, water will be removed. This is some of it says boil and some of it say evaporate, but nothing of them. Just remove. I say remove. Water will be removed. Okay, if water is removed after heating sometime strongly, we ensure that all the water has been removed. Then what should be the mass of the remaining things there? Should that increase or decrease? Decrease. Okay. I write value. This is here again. I may write here 1.6 gram. This is right. 106 gram now. Okay. And from these 3 masses, our experiment is finished. The experiment is finished. What we did first, we just have taken a container, right? When we measured its mass, could be anything. We write 100 gram here, and we take the sample. This is hydrated sample. Here with hydrated sample, here are 3 substances. Which 3 are here? Container and magnesium sulfate and water. Okay, 3 things together. And here this time we get 2 things here, right? Only 2 things: container and magnesium sulfate. This is, we say, anhydrous magnesium sulfate. Clear? From this data or information of the experiment, can you estimate mass of magnesium sulfate there and mass of water there? Okay, can you estimate from these results? What's the mass of magnesium sulfate will be here? 6. You said 6. How do you get 6? 110 minus. Yes, 106 minus 100, right? 106 minus 100, only 100, right? Right. And here are 2 things. One is the salt alone, right? Anhydrous salt that I talk about. Anhydrous salt is here, right? is no water. Water was driven out. Here is anhydrous salt, right? And also the container. Together it gives the mass 106, right? And only the container has mass. What's that? 100 gram. So how to get its mass? I write 106, which is the mass of the salt and the container, and subtract the mass of the container alone. It's 100. Clear? So this you get the mass, what? 6 gram. And water, what's the mass of water? He says 110 minus 106. Is this right? Is this okay? See here. Here are three things. One is the container. Another is magnesium sulfate, and another is water. Say again, which things are there? Container, magnesium sulfate, and water. Three things there. And here are two things, right? Which are two things? Container and the salt. If you subtract these two, you will get mass of the water, right? What is that? This is there, right? And I may get here what? 4. Yes, 4 gram. This is 6 gram. This is 4 gram. Now, can you convert them into their respective mole? You can convert them into the by dividing with their molar masses, as we did already, right? And you can round up the ratio to get the value of X. Clear? So again, look at the math. We already have salt. Here you got mass of the salt alone. What was that? 8.3 gram. And how did you get this? And mass of water there, 8.9. And remember how to get this? Like this experiment, with an experiment like this. Okay? They were together. They were together. The magnesium sulfate and water were together. Okay? And when we heated, they were separate. With the data, with the information, we have estimated their masses this way. And then you will convert them into their respective mole, and from mole ratio, you get the value. This is the 7. Clear? Everybody clear? Do you have anything to ask me to calculate this? I showed you that was the experiment you have calculated. This was the hydrated magnesium sulfate. When heated, you get anhydrous magnesium sulfate and water. The mass of dry crystals before heating. Dry crystals means hydrated crystals. This is hydrated crystals. Mass of water after heating. This mass was lost in mass. This mass we get actually what mass it loses. Okay, what mass is lost? That is the mass of. That is the mass of. The mass is lost. That is the mass of water. Okay, and you need to calculate this value. So we got this, and now we'll have exercise. আমরা এখন exercise আসবো.